I'm Umur, and I'm going to talk to you today about making Azure the best destination for running Postgres and why that matters for you and your applications. By way of introductions, I head up our Postgres product team here at Azure, and prior to that, I was one of the founders and the CEO at Citus Data. My Twitter handle is below, as well as our Postgres teams and the Citus Data. We founded Citus with Özgün and Sumit, and in fact, this is what we look like in real life. But we founded Citus really with an intent to change what's possible with Postgres, especially back then, and still now. Like relational databases are considered, very difficult to scale, and certainly, for Postgres. Right, as your database grows, as you get into bigger and bigger machines, how do you make sure that you can horizontally, elastically, scale? How can you make it behave as such? And that's the problem really that we tackled and continue to tackle actually. Now, if you look at Citus in a nutshell, this is our alicorn, which is taking the Postgres elephant and unifying it with the magical unicorn. So we basically making Postgres magical. The fundamental thing we do is transforming Postgres into a horizontally scalable database, right? So that means you can run it on a couple machines, you can run it on 10, 20, 50, 100 machines, but still have it behave like the awesome Postgres elephant. The other piece is we're doing all of this not as a fork from Postgres, which has traditionally been an approach to tackle similar problems, not this one, but adjacent problems. And we, in fact, don't do that. Instead of doing that, we extend Postgres using the powerful extension APIs and the machinery underneath, so that all the innovation that goes on in the Postgres community continues to accrue, right? And everything that gets done in the future, as well as what's been done to date, and all that ecosystem around it, can be immediately used with Citus. And we do this all in open source, right? And you can, of course, use Citus in open source, and we have a fully managed service of it on Azure. Now, it's not just us, thankfully, who thought this was a good idea. This is, in fact, even before the acquisition, the Windows telemetry team, or that's looking at data across hundreds of millions, pretty much, of devices, all Windows devices across the world, and looking at that data and making real-time decisions on what how to develop Windows further. All of that data right now resides on a Citus cluster. That's more than 2 petabytes of data, with queries responding in under a second across millions of queries pretty much every day. So the things that were thought to be not possible with Postgres are now are possible, and that's not, of course, just Microsoft. It's customers across pretty much all industries, whether from manufacturing to retail to healthcare to SaaS services, financial services, and pretty much all across the world. Companies rely on Citus to power their business, and we're really happy and proud to see that. Now, at Microsoft, when we look at Postgres, it's not just the Citus, but also the core project that we have a deep ties to. And here we have the awesome pictures of Thomas, Jeff, and Andres from left to right here as part of our team. We also have David Rowley, who at the time of this blog post hadn't joined just yet, which is just about kind of a few months ago. But really, having that core expertise as part of our team keeps us and our understanding of Postgres, close, but also very importantly allows us to contribute back, to the global project. The link below, which is aka.ms, that's just a URL shortener. So it's, you can type that in and learn more about this. So clearly, Microsoft loves Postgres. The Citus Data acquisition is part of that. The Postgres coders are part of that. But when you think about it, why is that the case? And not just for Microsoft, but why kind of for everyone does Postgres matter? So throughout this presentation, I'll talk about a few sections. First, kind of addressing that the current state of affairs, if you will, in the database landscape, and why kind of how Postgres sits there, and why it matters. Then what we do with it on Azure, and how we extend it to make it a really scalable database with Hyperscale Citus, and then combining all of that into how that's unique on Azure, and addressing or pointing towards some resources that you might want to look at later on. So looking at where things are today, right? This is just a relative popularity, if you will, of the different database engines published by DB Engines. And I'll make two observations here. The first one is that all the top 4 databases, all 4 of them are relational in nature, right? That's Oracle and SQL Server on the commercial side, and MySQL and Postgres on the open source side. And they not only have they been popular in the past, but they still remain the most popular, going forward. The other observation, obviously, is this kind of orange line at the bottom, which is Postgres, and how it's been trending up steadily. This is looking at the past few years, but has been the case over the more than 20 years since its existence. And when we look at how Postgres is perceived, this is just one way of looking at it. A recent Stack Overflow developer survey just last year ranked Postgres as one of the most loved databases. But then when you look at how it's getting used across companies, perhaps unsurprisingly, a lot of applications that are getting built on open source databases, right? More than 70% of them. And combine that with the fact that everything is pretty much more and more shifting towards the cloud, it almost creates a perfect storm for Postgres to continue thriving. But still, why is that? This is kind of a snapshot and a short look back at what's been the case, but why really Postgres? Right, then I'll bucket that under 3 groups. The first is that it is open source, right? And open source, there's a cost advantage to it. It's hard to beat free, right? But beyond that, really, it's not just that it's open source, but has a very large, thriving community around it, right? Whether it's the developers, whether it's the DBAs, whether it's all the vendors around it, all the tooling, it just popularity and that kind of user base creates a lot of value in and of itself. The other piece is that it's reliable, right? There are a lot of things in your stack that you might want to experiment with, but your database is probably not one of them. And Postgres has an excellent reputation for keeping your data safe, without any data loss, and secure, right? And the last piece is just this broad bucket around a very rich feature set, right? Whether that's how you use indexes, how you use different data types. For example, JSONB is a very popular, relatively recent, but still, it's been multiple years now since its introduction, allowing you to store, JSON data directly in your, database, and store it in a binary way, index it, and really have fast access to it. And of course, the list goes on and on, how you can access geospatial data with PostGIS, the different types of indexes, all the kind of relational functionality that's robust and built into Postgres. So all of these kind of create the basis for why Postgres is so popular, right? Now, when we look at what we do with Postgres on Azure, we provide a database as a service or a platform as a service on top of it, which essentially means, right, we keep the kind of all the goodness, all the core around it, or what makes Postgres great, and then really make it easier to manage, whether that's taking automated backups or failing you over when failures occur in the system, keeping it secure, patching it automatically, and so forth. So if one of the, of course, good things about Postgres is you can run it anywhere, right? You could run it yourself. You could run it on a Docker container on your laptop. You could run it on kind of any cloud provider. Now, if you were to manage things yourself, you would take care of this entire stack like yourself, from provisioning even the hardware all the way up to managing the database. If you use an IaaS approach, which is infrastructure as a service, run it on VMs provided by a cloud provider, then it take care of the things at the bottom highlighted in blue, kind of on Azure, right? So you would take care of the provisioning and the virtualization. And then if you take that further to a PaaS or a platform as a service approach, then we're actually beyond the operating system, but we're actually deploying the database, maintaining it for you, patching it for you, and then doing even further optimizations like making intelligent recommendations on what you might want to index, or if we get a threat to your database, if we detect that, raising alerts and so forth. In all cases though, the application is maintained by you, and then the same thing, the data belongs to you, right? The data is stored in a different environment, but it's encrypted and it belongs to the customer, right? Now, when we look into how Citus plays into this, and Hyperscale Citus as it's called within Azure, it really changes how we think about scale, right? And I talked about this a bit earlier, kind of at the top of the talk, but really the problem occurs when you have bigger and bigger data sets, which you kind of upgrade into bigger and bigger boxes, and at one point there's no more place to grow to, or even aside from that, as your databases get bigger, they also become more fragile. Like backing them up takes longer. Failing them over takes longer. For those of you familiar with Postgres, running vacuum or maintaining it, like everything becomes more fragile as your database gets bigger. And at Citus, we basically change that. We take a slider, if you will, and whether you're running 2 nodes or 10 nodes or 100 nodes, you basically drag the slider, and your application doesn't need to know all the complexity of sharding and distributing your database underneath, right? So you have access now to all the cumulative resources of the cluster, all the memory, all the CPU, all the storage, right? Without having to bleed that complexity into the application layer, and you're talking to kind of a single Postgres endpoint. That's basically what we do with Citus. And the way you access this is on Azure is one of 2 ways. Our Azure Database for Postgres, which is our PaaS offering, you could deploy it as a single server, which is standard Postgres, or you could use Hyperscale Citus Server Group. Of course, Citus itself is open source. aka.ms/Citus will take you to our GitHub page, where you can see really what we're doing. You can also, if you'd like to contribute, that's always, of course, very welcome. So, but we do this kind of all in the open. There's one other piece that I want to talk about on how you can use Citus, which is through something we call Azure Arc. And that's something we introduced quite recently, and something I'm super excited about. It's in preview. What that allows you to do is really take all the manageability that we talked about, from provisioning to monitoring to automatic failover and backups, all of those, that machinery, if you will, and run that on your premises. And wherever your premises might be, it could be your own data center, it could be a different cloud provider, what we rely on for doing that is having Kubernetes running underneath, right? And that could be your own Kubernetes that you manage. It could be a cloud provider like AKS or your Google's or Amazon's, or it could be OpenShift. Doesn't really matter, but fundamentally leveraging that infrastructure to bring the manageability to your premises. This is again in preview, but through this link you can learn more. Now, putting all of this together, what makes Azure really unique for Postgres? If you look at the core of those 3 pillars that makes Postgres so valuable and so popular, we preserve all of them, right? And on the open source side, we not only preserve it, but we give back through contributing code to the project with the core committers, but also maintaining different extensions. And Citus is of course one of the big ones there, but there is other extensions that our team maintains, including PG cron, including CStore FDW, HLL, and a bunch of others, which basically kind of gives back to the community. This is unlike other cloud providers, where an approach is more of keeping things just behind the walled garden and keeping kind of proprietary forked versions of it. Then on top of that core foundation, we provide these kind of light blue boxes of manageability, which I talked about earlier, Hyperscale Citus for scalability, and also Azure Arc for running anywhere, right? And then having a best-in-class security piece around it kind of completes the picture from from a manageability perspective, and then we integrate all of this with the Azure ecosystem, right? And that could mean, for example, using Power BI to visualize your reports. It could be using Azure Data Studio, or it could be Azure Data Factory to move data. And all of these are optional components, right, which you don't have to integrate with, but they are available at your disposal and very easy to integrate with, making that experience quicker, smoother, if you will. And if you think about the whole picture, there is no other cloud provider who offers all of these pieces, right? On the open source side, the traditional approach is kind of forking and creating a different version of Postgres and keeping it closed. On scalability, Hyperscale Citus as a fully managed service, is available only on Azure. Azure Arc gives you that flexibility. Security, we've talked a little bit about. That's in and of itself a huge topic. But things like integrations like Azure AAD, for example, Azure Active Directory, making that really simple and seamless, or intelligent, threat detection. We call that advanced threat protection, by kind of sensing the threats that are kind of unusual, if you will, or patterns that are unusual on your database, and kind of raising the flag for you. It's a complete package that is very unique to Azure, and that's how we make Azure a unique destination for Postgres. And this is just one integration point I did want to call out. It's Azure Data Studio, and a lot of people that I speak with are often surprised to find out that Azure Data Studio supports Postgres. They often think it's just a SQL Server or a Azure SQL benefit, but in reality it's it just integrates nicely. And also same with MySQL, Azure Data Studio has those integration points allowing you to kind of manage your database. Again, these are all optional. You could use pgadmin if you wanted to. You could use pSQL and just have or whatever basically is your favorite tool to access Postgres. But we invest in making this better, and we keep, again, in the spirit of open source, all of these open. So Azure Data Studio and its Postgres extension are open source for access. And finally, on some of the use cases and resources that we frequently see, right? So on the single server side, which is the vanilla Postgres usage, a lot of new apps are getting built on Postgres, whether that's on Kubernetes, leveraging Azure Kubernetes service, or frameworks like Python and Django. It could be on app services. It could be leveraging Rails or Java with Hibernate. Basically, a new kind of class of apps. Postgres is a very natural destination for them. Another pattern is lifting and shifting kind of our existing Postgres, which you're already running on premises or elsewhere and managing yourself, and then moving that to PaaS, or platform as a service, or even IaaS on Azure. And last not least, we see quite a bit of users moving away from Oracle and into Postgres. Sometimes that's an entire migration, just moving away from the application entirely. Sometimes it's offloading it, creating different instances where analytics can be run, or different components of it can be run, or new applications getting built on Postgres. And the reason that Postgres is very popular in those scenarios is it's syntactically and functionally quite similar to Oracle, including not just the SQL piece, but also stored procedures like PL SQL on Oracle maps very closely to PLPG SQL on Postgres. And again, like any migration could be different levels of effort. Sometimes it's relatively straightforward, sometimes it's relatively complex, but Postgres itself is the closest often destination to Oracle, and we see a lot of people moving in that direction. And when you look at it holistically, it's digital transformations as companies go through that, looking at the data at the center of it, and Postgres sits kind of at that core. And as people are building modern relational applications, again, Postgres sits very nicely there. For hyperscale Citus, use cases revolve around, again, three topics. One has to do with these very kind of rich customer applications where you have transactions that are happening, also analytics running kind of on those transactions to provide your customers a kind of an interactive experience. Sometimes these are referred to as HTAP, hybrid transaction analytics workloads. They often involve a lot of data. That could be time series data that accumulates. It could be event data, and it's a lot of sometimes it's rich JSON or geospatial data. But fundamentally, these applications tend to be compute heavy and memory heavy, right? And then by virtue of using Hyperscale Citus, adding more compute, it makes it more much more performant and a very good fit. Another use case is the multi-tenant SaaS apps, and in this case, what we see is almost all SaaS applications share a pattern, which is your customers, meaning your tenants who are using the SaaS application, need to see all of their data, obviously, but should not see anybody else's data, any other tenant's data. So, but as a maintainer of the application yourself, you want to be able to look across the tenants when needed, query across them, share data between them, isolate specific tenants for whether security purposes or for performance reasons, but all of that pattern lends itself actually very well to dividing data by tenant, and Hyperscale Citus gives a great framework to do that really simply. And last, we have use cases where a single node Postgres is just not sufficient to from a performance perspective, where there's a lot of transactions happening, and you can rely on Citus to handle those. And if you look at that, end to end, it could be starting as low as like tens of gigabytes as you kind of grow your database up to petabytes when you're still using Postgres, whether it's on a single node to begin with, or like tens of nodes or hundreds of nodes with Citus later on. This is the example I was alluding to earlier at Microsoft, where there's more than a petabyte of data. There's a blog post here that talks about some of the details, and it really covers how it's architected. And if you're interested, it's an excellent read. But then on the other end of it, data could be a lot smaller. And this is one of the largest banks, for example, in New Zealand, and it's like a SaaS application where through using Hyperscale Citus, they can onboard customers more than 20 times faster, right? So in essence, you don't have to have petabyte scale or even tens of terabyte scale data, but as you think about building scalable, cloud native modern applications, Postgres and Hyperscale Citus sit smack in the middle of that. So in summary, if I leave you with like 3 thoughts on as you think about Postgres and as you think about Azure, some of the key pieces to remember. First is of course Hyperscale Citus, that it allows you to scale out horizontally. The other is the commitment, our commitment to open source, not just using Postgres, but actually investing in its future. And complementing all of this experience with the Azure ecosystem, all of the tooling that's available to you with a few clicks if you choose to use them, and if not, just integrating really well with all the open source and other tools that you use today. So a few resources if you like to take a look afterwards. The top left is our Azure Database for Postgres product page. We have a lot of blogs on the upper right, quick start guides to get you going, migration guide to move your data. Bottom left will take you to the Citus open source page, and then you can always ask us questions via email at askazure.db for PostgreSQL. One last comment for we have a monthly newsletter it's called the Citus newsletter. You can go to that link, and it basically sends you a lot of technical content at the end of each month that talks about how you can leverage Postgres and Hyperscale Citus in your applications. With that, I want to thank all of you for being here. And for those of you who are attending the event, I'll be available for live Q&A. Thanks, and we look forward to seeing what you can do with Postgres on Azure. Thank you.